Hello, welcome to the last part of our lecture entitled More on Triple Integrals in Rectangular Coordinates. So now we'll try to do some exercises at the end of the slides. So what we're gonna do is we will do number 1 and number 2A. Number 2B, it's very simple. You can do this and you should get the answer 1. Letter C, I think this is quite complicated just because the solid is very hard to imagine. But if you can imagine okay, but first you have to look at the integrand. The integrand is e to the minus z squared, and this is with respect to z. And because this is with respect to z, you have to look at this function. And you know maybe from the topic on switching the order of integration in double integrals that this is not integrable. And the only way to do this is to have a switching of the order of integration. So instead of dz dy dx, I think what you can do is to write this in dy dz dx. So here this is type xy, and you want to write it in type xz. Okay, so it's quite hard to imagine the solid, but I hope you can find I mean you can imagine the solid and get this iterated triple integral. You have 0 to 1, 0 to x, 0 to z of x e to the minus z squared dy dz dx. And when you do that, this is now better and it is solvable, and the answer should be 1 over 4e. Okay, so for letter B and letter C, this will serve as your exercises, and we will do number 1 and number 2a after this. Okay, so let's look at number 1. So use triple integrals to find the volume of the tetrahedron enclosed by the coordinate planes and the plane 3x minus y minus 2z equals 12. So again, if you want to draw the plane, what you want is to get the intercepts. So if y and z are 0, x would be equal to 4. That's why 4 is here. If x and z are 0, then y would be equal to uh, minus 12. Y should be equal to minus 12. Sorry, my drawing is quite wrong, but if I just put minus 12, then it's fine. Is it the same thing? Yeah. And when x and y are 0, then z should be minus 6. So you have minus 6 over here. Okay? So please don't mind that minus 12 is shorter than minus 6. Okay? Um, anyway, so we want to find the volume of the tetrahedron, and when we talk about volume, what we really do mean is we want to triple integrate 1 dv over the solid G, which G is the tetrahedron. Okay, so now this is a solid of type XY. So because it's type xy, the next thing that we have to do is to draw the projection r. So the projection r is on, so x is positive and y is negative, so that means you are in the fourth quadrant. And so the x-intercept, remember what was 4. The y-intercept, remember it's minus 12. So you just have to draw this triangle, and this is your R. And if you treat this as a type 1 region, so this is the set of all xy such that y, well, x ranges from 0 to 4. That one is clear. And y, if you imagine a vertical strip here, then the bottom function is this one. And what is the equation of that one? The equation is just let z equals 0 here. Just let z equals 0 here. So that's 3x minus y equals 12. So 3x minus y equals 12, right? So that means that y is between, so if you isolate y here, you get 3x minus 12, and the top function is nothing but the x-axis, which is y equals 0. So now we have a double integral over r of another integral 1 dz, because you're integrating because you're finding the volume, so the integrand is 1. This is dA. So what you want to find now are the limits of integration of this integral. So the limits of integration is nothing but the floor and the ceiling functions. So now let's just draw an imaginary vertical strip here. So the top function, the ceiling function, is the xy plane, which has equation z equals 0, and the floor function is this, right? It's this surface, and you have to isolate z in terms of x and y. So maybe let me just do that here. So you have 2z equals 3x minus y minus 12. So therefore, if you divide everything by 2, it will become 3x minus y minus 12 all over 2. Okay? So that is your intermediate step, before going to the fully iterated triple integral. So this would be equal to the integral. So remember that we have already found the limits of integration of the region R. So let's proceed. So the outermost limits of integration will be 0 to 4, and that will correspond to dx. Next is 3x minus 12 to 0, corresponding to dy. And finally, let's just copy this one. On the left, you have 3x minus y minus 12 all over 2 to 0, and you're integrating 1 because you're finding the volume. Alright, and this would correspond to dz. Okay, so do you want to finish this one? So maybe I'll do one more step, and I think the next steps would be cumbersome. So I maybe I would leave I would leave the final answer to you. But the integral of 1 with respect to z would be z. So this would be equal to integral from 0 to 4. Let me just recall, 3x minus 12 to 0, and then I have z here evaluated from 3x minus y, I think, minus 12 over 2 to 0 dy dx. Is it correct? Yeah, I think so. So this would be equal to 0 to 4, 3x minus 12 to 0. And then I have minus, because when z equals 0, then everything is 0. So I just, maybe for emphasis, I put 0 there. And then I have 3x minus y minus 12 over 2, and then dy dx. Okay, so this would be equal to minus 1 half integral from 0 to 4. So the minus 1 half comes from this part here. Okay, and then maybe I right away integrate with respect to y here. So I have 3xy minus y squared over 2 minus 12y, and then you evaluate y equals 3x minus 12 to 0 dx. And so maybe this is the last line that I would care to solve. So I have minus 1 half here, 0 to 4. When y is 0, everything is 0. And then when y is 3x minus 12, you get 3x. 3x minus 12 minus the square of 3x minus 12 over 2 minus 12 times 3x minus 12. So do you understand what I meant by by having this integral as quite cumbersome? Because well, what you can do now is you can factor out 3x minus 12. You can expand this as well. But I'll just give you the final answer, and maybe I'll cheat a little here. I'll use the formula that we learned from grade school. Tama ba, grade school? So, the volume of a tetrahedron is nothing but 1/3 base times height. And so this is equal to 1/3. The area of the base is 1/2 because it's a triangle, and then the base would be 12, the height would be 4, and then the height of the whole tetrahedron is 6. So 3 times 2 cancel with 6, so this would be 48. So I think after everything, you should get the answer 48. Okay, and I'll leave this as an exercise in routine evaluation of integrals. All right, so let's proceed to the next item. So evaluate the following triple integrals. So let's just do the triple integral of z dv, where g is bounded by the cylinder y squared plus z squared equals 9, and the planes x equals 0, y equals 3x, and z equals 0 in the first octant. So what I did was to draw y squared plus z squared equals 9 on the yz plane, and it's a circle, but because it's in the first octant, I just drew the quarter circle, and I knew that because it's a cylinder, then that means that it will be propagated along the axis of the missing variable, which is x. So that is the cylinder y squared plus z squared equals 9. But we have to note also that there's another boundary, which is y equals 3x. And this is again another cylinder because z is missing. So I'm just going to draw y equals 3x on the xy plane and then propagate it along the z-axis. So you see, this is a boundary of the solid, and so you have a circular cylinder over here, and then you have a plane here. So I hope you can imagine that this is the solid, right? And this is clearly a solid of type XY because we can define the projection onto the XY plane. It's nothing but a triangle. So you have here the projection R is the triangle on the first quadrant. Sorry, this should be a YZ plane, right? No, 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 no. Sorry, this is an XY plane because we're treating this as a solid of type XY. You can also treat this as a solid of type YZ, and I was thinking that one, but we want it to be a solid of type XY because that's the more natural thing to do. You want to project to the ground, right? So let me correct that. This is on the XY plane. Here, so you have y equals 3x. Y equals 3x would look like that because the slope is equal to 3, and then y would be equal to 3. It's a y-intercept, so that means that here it's 1. So here, if you view this as a type 1 region, y is between where and where? So that the function below is y equals 3x. Y equals 3x is the bottom function. The top function is y equals 3. And then x here ranges from 0 to 1. So on the other hand, the elevation, the roof, and the floor functions are, well, here you have z equals 0, the xy plane is the floor function, and the ceiling function is z equals the square root of 9 minus y squared. So I'm just going to give you the setup integral. So the setup integral will be integral from 0 to 1, that will correspond to dx, integral from 3x to 3 corresponding to dy, and finally the integral from 0 to square root of 9 minus y squared corresponding to dz, and finally I just put z here as my integrand. Okay? So I'm not gonna finish the solution because this is now the most important part of the solution. I think it's easier now to do the step-by-step solution to finding the value of this. Okay, so I hope you learned something today. So this is the end of the lecture about triple integrals.